All right, so for question number 2, we have Science Kyle. He's riding his skateboard east with a momentum of 50 kilogram meters per second. He pushes on the ground. He experiences a net force of 10 newtons to the east, so the same direction, for 2 seconds. We want to know what is his change in momentum, what is his final momentum after the interaction with the ground, and then if Kyle has a mass of 30, how fast is he moving after that interaction, right? So I've again gone ahead and drawn a diagram of Science Kyle. We know that he's initially traveling with a momentum of 50 kilogram meters per second. And if he's applying a net force in the same direction that he's moving, right, we can assume that he's probably going to increase his speed, right? If you're cruising along eastward and you get a boost, like a force, an interaction in the eastward direction, you're probably going to speed up. So I've gone ahead and drawn my vectors to kind of reflect that. We don't yet know what his final momentum is, but to figure out his change in momentum, okay, recall that a change in momentum is equal to the force that's applied over a certain period of time. Okay, so if you have a really, really big force, right, that's going to change your momentum quite a bit. If you have that force and you apply that force for an extended period of time, right, that's also going to increase your change in momentum. So these are all directly proportional to impulse, to your change in momentum. So I'm just going to keep this handy here. So to solve for the impulse, my change in momentum, that's equal to the net force over the period of time. Well, it did say that the net force was 10 newtons, so 10 newtons, and then I'm going to multiply that by the change in time, which was 2 seconds. Okay, so our impulse is 10 times 2, so that's 20. And recall that impulse is a change in momentum, so that'll be measured in kilogram meters per second. Okay, so we are good with number A, or letter A. Letter B, what is Kyle's final momentum then after that interaction with the ground? So we know what his initial momentum was. We know what the change was. If we want to know what the final is, we're just going to add these two values together, right? Because we had 50, we experienced a net gain of 20, so 50 plus 20, 50 plus 20, that's going to give us 70. That'll be kilogram meters per second. Okay, so that's his final momentum after all this is said and done. Now we need to know if Kyle has a mass of 30 kilograms, how fast is he moving after the interaction? Recall that momentum, okay, can tell us a little bit about the speed, because if we know the momentum and we know the mass, we can do a little algebra to solve for the velocity. Okay, so I'm just going to leave my space down here. I know that his final momentum was 70 kilogram meters per second. I know that his mass is 30 kilograms. Okay, and so now we're just looking for his final velocity, right? So with a little bit of algebra, okay, to solve for velocity, right, what times 30 gives us 70? We divide both sides by 30. I'm getting 2.33, okay, so that's going to be the velocity. 2.33 meters per second is the final velocity of Science Kyle on his skateboard.